Hello and thank you for joining. I'm Gary Clarkson. I'm an applications engineer for Crank Software. I'm based in the UK and I look after our European customers and into Asia. So my role really is to help our customers develop and design applications with Storyboard. And today I'll be taking you through our session, which is streamlining brilliant graphics with MCUs on the NXP platform. And I'll be using Storyboard and MCUXpresso to create a user interface for you. So a quick look at our agenda. So during the session, I'm going to give you a quick, very quick, obviously. Don't want to get too deep into the marketing. This is pretty much a technical session. So a bit of an introduction to Storyboard if you've not seen it before, and also Crank Software as a company. And then I'll take you through a design workflow, and this is going to be using Photoshop to create a user interface, a GUI, and then bringing that into Storyboard and then bringing it alive. Adding animations and other navigation aspects, and then I'll be taking you the steps and some of the considerations for preparing your application for deployment to a target. So this is looking from moving from a desktop environment to the embedded target and what that entails. And then I'll actually do some development with you. I'll take you through integrating this user interface with whatever MCU code you have. So bringing the MCU and the HMI code together. And I'll be using the MCUXpresso tools and the i.MX RT1060 platform for the hardware. So hopefully this session is going to be useful. I'll leave it there and I'll take you through the sessions. Okay, I've turned my webcam off and that's enough about me. Let's now take you through a very quick introduction of Crank Software and also Storyboard, our product, and really explain what we're all about. So as it says there, we're all about embedded GUI design and development tools. So Storyboard started life, I guess, around 2 decades ago. The founders of Crank Software have a lot of experience in developing applications for embedded devices. And going back 20 years or so, this used to be a much more painful process as it is today. But we've really tried to focus on taking what the hard components are, the hard aspects of developing a user interface, specific for an embedded platform, and also making it as easy as possible. So over that time, we've integrated lots of tools and techniques into Storyboard as a product that makes it as simple and efficient as possible. So one of those key cornerstones is the ability to decouple the front end, the UI, from the back end logic. So this is a state machine that's actually working the device. So this could be spinning motors, it could be turning lights on, heaters, whatever. So really the ability to decouple comes in 2 stages. The first one is it allows you to develop on your desktop and simulate and test on your desktop the user interface, and also it allows you really to separate the logic, the control and the UI into separate worlds, really. So if you think an application is very asynchronous, the user input can come at any time, and you want that to be really fluid despite whatever else the application is doing, so the code that's running in the background. So to do that, we've got a pretty good back-end, front-end integration architecture and a clean API that allows you to have them connected together to exchange messaging events. And really, this is the same on a microcontroller platform as it is on a microprocessor platform, something like an application processor, a Cortex-A class. Today, we'll be focusing on Cortex-M class MCU. So this is going to be a proper embedded target, such as you'd like to use as a something in maybe a consumer appliance. So it's very easy to use a multi-core application processor with GPUs and lots of memory to achieve a nice rich user interface. It's much harder to achieve that on an MCU. So what I'll show is the workflows throughout this presentation of basically how firstly you're creating the user interface in the first place, from its component parts, its assets and its fluid design, and then then taking that through to development using the code tools, and then deployment to target hardware and see how that works. So the last thing I wanted to mention was that Storyboard really is a bridging tool. So this is a really key component of the UI development process. Really, is to engage those design guys, the guys who are drawing the assets and have the user interface, the user experience capability and the flow. And taking that knowledge and bringing that much closer to the application developers on the code side. So we're allowing the GUI tools and the GUI designers to become much more integrated into this workflow process. This allows you to evolve the design much faster, to move images around and to change colors and things without really necessitating a huge amount of software development. So really it's a very good collaboration tool, and it allows you really to look at the way that your team is structured and maybe change it around a bit to bring the teams closer together, so it's not such a cut and dry process. So I'll take you through the workflow, and the first thing I want to show you is how you can start the application, the UI up front. Let's look at the design workflow for creating a user interface, a GUI design in something like Photoshop, and then bringing that through into Storyboard. So I'll show you here. This is my Photoshop environment. I'm not a graphics designer. I'm a software guy, so I'll keep this brief. My knowledge is fairly low on this. So let's zoom in a little. Control plus. Okay, you can probably see that this is made up of a number of screens. So we've got a kind of a wall thermostat design. So 1, 2, 3, 4, 5 screens or so. So each of these screens is using something called artboards in Photoshop, and an artboard is a way of clustering images and graphics and controls onto a single form. This is going to represent a screen when we import it to Storyboard. You can see if I hide all the layers here. So on the thermostat screen, we've got some content in the middle, and we've got a background layer, which is a basic background image. On top of that, we've got a menu layer we're using for navigation, and on top of that is a scrolling menu. So this is a brief hierarchical view. So the thermostat screen itself contains layers, and layers have controls, and controls have attributes. So we've got some mixture of images and text, such as the text in the middle here. So I won't go into more details, but some of the naming standards is up to you. You can call it whatever you like. You can see we've got underscore up and underscore down. We use that to automate some of the button control behaviors. But essentially, it's it's a hierarchical structure. Screens have layers, layers have controls, and controls have primitives. So what I can do now is show you how we take that into a Storyboard world. So we've got an import PSD function here. So if I kick that off, and I'll just pull in that file we were just looking at. This is designed for 480 by 272. So I'm choosing to create a new project. This is file new, day 0. So it's a new design. You could merge it into an existing project, but I'm doing a new one here. And what I was going to do is going to deconstruct that PSD file and recreate it in Storyboard format. So very quickly, we've got all of our controls and everything laid out in screens here, matching what was in Photoshop. And you can see on the side, we've got those represented in the application, and this is what we call the application model view. Thermostat layer. You can see here we can show and hide all of these things. Okay, so very much similar to what we see in the application inside of Photoshop is now recreated inside of Storyboard. So we brought in all of the assets, all of the values. For example, this text in the middle is text, so I can change that to 22. You see what you see is what you get. We brought in its font attributes, everything else. And we're ready really now to start working with that design and doing something with it. So the next stage really is to add some flows and behaviors. So well, I'll do one quickly, and then I'll show you the rest of it. already done, so just to save a bit of time. So you can see here we got some buttons. When you click on a button, you can see, if I go to the control centric view, there's some behaviors with press and release and outbound, and these simply change the up and down image. So pressed is one image and normal is up and down. Okay, so that's a really quick way of as you saw, was bringing in those controls already made. I want to move this menu, and I'm going to do some other stuff. So even at this point, we're starting to see the application come together. So one of the things I'll do is I'll show you quickly just adding some navigation behavior. So let's take this menu and hide it. All of those things. You'll see that's offset of -1, so I'm going to do -171, so that should take it off the screen. I'm going to do some animation now. I'll show you how I've done that in a moment. But these buttons here, we're going to do some work with, and these things on the bottom here, these navigation icons, we're able to move around. So I'm going to add everything in Storyboard is an action. So an action is triggered by something. So this is triggered by a touch, and I'm going to use that to transition between the screens. So I'm going to touch on thermostat, goes to thermostat screen. You get the idea. So weather goes to weather, transition to weather, etc. Okay, so I've done a couple of those. Finally, I'll do the setting screen. And settings, general. Okay, so I'll just show you quickly. If I save that and run it, the simulate button here runs that model, those assets inside of Storyboard, and you can see that here. And I've got some navigation here that takes me through to the different screens. Okay, so I'll show you one that's already made, but I'll be animating that menu, and also I'll be doing some behaviors with these controls here. So to save a bit of time, I'll flip over to my navigator view. But before I do, I'll just show you the deconstruction process has actually brought in all of those assets as images. You can see them all here, various shadows and bitmap images and what have you. So those are the constituent parts, the assets of that application. What we've also got is the model file here. The GDE file is our metadata, our model file, which describes all of that. So I'm going to close that one and switch to one I've already done. Here's one I prepared earlier. So what I've done is, if I open that, I'll show you running first, and I'll describe briefly how I did it. So it's the same base application. What I've gone through, and I've done some extra work. I'm going to be navigating between the screens there, but I've also added the ability to bring in the menu. So there's an animation there, bring in the menu, and hide it again, and also some conditional logic to increase and decrease. And you see I've limited it to 30 on the top end and 16 on the bottom end. Okay, so subtly there's also the press and release images, but you can see there's a glow behind the screen of the background. So those are simply added first of all by adding an animation. And what I did, I recorded moving things backwards and forwards. If I show you that, so the hide option, okay, I'll show you the other one first, sorry, the show option. So the show is basically, I moved it off screen, and then I'm moving it from a -170 position to -1. So that's going to bring in the X positions of all of those things that I moved off the menu function, and bring it into the screen. And we've got an animation preview here, which I can show you that in action. So it's what you expect. So that's going to be moving it in. And also we've got the ability to create a reversed animation. So the hide is taking that and then doing it in reverse. Okay. So basically that's a mirror image to show and hide, and I attached the actions to that region, that pizza box icon is now triggering an animation. Before I did screen transition, now it's actually run an animation, and it's difficult to show, but if I show you on this, I've done the same thing here on the that menu hide is triggered by clicking on that first row of the menu. So the important thing there is it's very easy to do. We've got an animation recorder and preview, and it's probably not time for it today, but I can just you can see some examples of how you do this on our website. But that basically records the changes you've made to the UI over time, and then takes a snapshot and then stitches them together and builds up the multi-step animation you've got here. Okay. So the last thing I want to show you is really regarding some of the behavior. So we've got Lua. Lua is a language which is built into Storyboard, and it's a common language in the gaming environment. And these really allow us to add some conditional behaviors. So you saw before that when you press on one of these icons, I've added an action. Go to the actions view. Which is calling not a data change to change the image or screen transition. This action was to call a piece of Lua, so the function callback to Lua. And what I did, I created a function here called increase temp, which is doing some very simple range limiting, and crucially the value that we're going to change is that text in the middle, and it's also changing that same value on another screen. So we're building up the value of the temperature number in the middle. And to do that, what I did was I added a variable. I'll show you the variables view. So I can right click and add a variable, and what this allows you to do is bind to something. So here's the text variable I've created that variable using that binding icon, called it text and given it a value of 20. That now is a dynamic field that I can change at runtime, and I'm doing that in Lua, which is what I'm doing here. I'm setting the value. That set value function is an extension that we've added to Lua, and that's going to trigger the render engine, the data manager in the render engine, to update any of the screens referencing that particular that binding. So it's going to trigger a render of that piece of text if it's displayed. And the last thing was the glowing surround for the center thing. That's actually not created using the snapshot recorder. In this case, I'm using the GRE extension of Create Animation. This allows me to do it programmatically rather than kind of beforehand, so you can build up these things in script as well. So what I'm doing here is I'm bound to the alpha value of that control, the visibility, and I've bound to that, and I'm changing it from 0 to 255, so completely transparent to fully opaque. And I'm doing that over a quarter of a second. So that's the first step. So the fade in, and then the fade out does it in reverse. So 255 to 0. And then finally, I'm triggering that with a code, with some code here. The trigger animation basically kicks that off whenever I press one of these buttons. So that's how we got that effect. So that's all fantastic. We've now got to really consider not only the initial design, but we need to deploy that to the target, and for that we need to take a step back really and look more at some of the architectural guidelines and some of the steps we need to do to consider how that's done. But we'll be taking some steps to customize this to target it at a particular hardware platform next. So when we're looking at preparing for deployment, it's all about moving from a desktop to the target, and you need to think about a few things here. So some brief design decisions, and I'll make a shameless plug to the white paper and an ebook we've got on the website. So we do have a lot more detailed explanation of all of this. So I'd encourage you to go and read that. But briefly, if you're looking for a rich responsive UI, you need to balance the system dynamics. So we're talking CPU, memory, and I/O resources, and of course you've got to choose that up front. So you've got to think about some of the aspects of the system. Here I've pulled out 5 of them. So the core CPU, we've got support from something really lightweight with our engine, from a cortex-m3, M33, M4 class, maybe M7, which we're using today, all the way up to multi-core cortex-A class processors. Those will be running, running with graphics acceleration perhaps. Some platforms have it, some don't. So we always provide a basic software render support. But if there is 2 or 3D hardware, such as DMA2D, PXP or OpenVG, etc., we're able to leverage that for higher performance. Memory is a big thing. So memory is probably one of your key considerations. So Storyboard uses memory, of course. We use it for model data, but also primarily really for the pixel data. So this is the raw images and things. So it's important that there's not only enough memory, but there's also the right mix of it. So whether it is faster internal memory or slower external memory. And one of the big drivers really is the size of the display. So when you're choosing a display, it's not about the physical size, so it's like 7-inch or 10.4 inch, etc. It's the number of pixels. So pixels means memory, and memory needs bus bandwidth to move and CPU to manipulate. We'll come on to that in a bit more detail. And in terms of the operating system, Storyboard can run on anything, really. We often get asked about bare metal. So really, fundamentally a HMI is asynchronous. So you really need the concept of a task, a scheduler, to be able to manage the kind of front-facing UI tasks with background operational tasks, spinning motors, blinking LEDs or whatever else your application does. So you need a kind of a task construct. Along with that is synchronization to manage those tasks, so semaphores and mutexes and thread locks and such. Critically, memory management is a key thing again. We use heap and dynamic memory. This is for inflation buffers and all sorts of things. We're very good at reusing that and recycling it, but it needs to be managed, so you can't just statically allocate it. And to communicate between the front end and back end state machines, you need queues, and we send events backwards and forwards using queues. And the whole thing ticks along using timers. So we need timers backed by hardware typically, but these are for driving animations and sequencing the whole thing. So I'd encourage you to check out the white paper. So in terms of application, how much memory do you need? I mentioned pixel buffer, so that's all about the screen, which I'll come on to in a second. But we need a bit of working memory. This is the inflation, and a rough guide is kind of just to run the model and start Storyboard up and everything else it does. We need about 100 kilobytes as a base, okay. And on top of that, we need to consider the display. So for a 480 by 272 display, like we'll have on the board. You're looking at 500K or so if you're using 32 bits per pixel, or 260K for a 16-bit 2 bytes per pixel display. And critically, also most systems use double buffering. So this is a technique where the graphics engine draws to one buffer while the LCD is pointing at another. And when the frame is completely rendered, then you flip the buffers. So this prevents tearing and other rendering artifacts being displayed when you're actually viewing the screen. So you can see how quickly you can start to calculate the amount of memory. And we'll come on to techniques in a moment. So also, Lua is a scripting engine which we were using before to do some of the UI manipulation and the dynamic behavior. It has some overhead. It's very simple to use, and that's why we chose it. It's basically glue logic to do conditional and a kind of other dynamic behavior. It's an interpreter which is built into our runtime, and it's really good because it's cross-platform, and there are no compilers. So you simulate on a desktop, and it's the same on the target. No cross-compilation. Very small and efficient. Came from the gaming industry, and it has really good memory control, even on resources, very limited targets. And really, a consideration is that in terms of using Lua, it does use memory. It uses dynamic memory, as we mentioned before. It's hard to predict exactly how much, but you can profile it during runtime, and it uses garbage collection. And we've actually got another white paper article on our website that discusses Lua in much more detail. So I'd encourage you to go and read that as well. So Lua is there. You don't actually have to use Lua. We have alternatives for microcontroller targets. If memory is at a real premium, we have something called native C callbacks. So you're able to call out of your storyboard model like we did with a Lua callback. There's a native C callback, so you can put in C code and remove any overhead for the Lua interpreter. Okay. And in terms of the application itself, how much memory does it take? Well, it depends. It depends on complexity, the number of screens, number of controls and images, and a whole heap of reasons. So for that matter, what I'll show you next really is all about the resource metrics. So if I switch back to my storyboard model, we've built in some capabilities to look at deployment really. So as you're going along, the application is being assessed continually for the size of memory it's using, and in this current configuration, it's using 83K of memory for the in addition to what I've just mentioned, in addition to the frame buffer and the working memory. So 83K is roughly what it's needing for inflation and various other things. And the storage in terms of flash is there. So what you can see here, if you look at images, we're going to be storing a lot in uncompressed form in Flash in this configuration. But let's switch from that now to resources. So you can see the screens, and you can drill down to each of these screens and see what the contribution to overall footprint is. Background layer, of course, that's a full screen image, which is like 500K. Okay, so that's how much memory it takes to draw the screen effectively. So when we're deploying to the target, we're able to create what we call a custom configuration. So this application, I can click on the configuration screen. I'll change that back to the default. So file system there. So normally, if you're on a high-level operating system, you'll be deploying as files, and you'll have a lot of memory. So Linux has got usually hundreds of megs of memory free, so it's not much of an issue. But here we're deploying to a virtual file system, so I'm going to create a new I've already created one actually, a new configuration which is targeting Flash. So we're actually using a virtual file system rather than a full file system, so we don't need the file system objects. And I've chosen in this first step to do native format. So this is storing things in compressed form, so native PNGs. What that means is that the flash storage is 1.26 megs, so it's relatively minor, but the RAM is now at 4.1 meg, so that's quite a lot of space, and that's because we're inflating all these images. It takes CPU and memory to inflate the buffers there for drawing. What we can do is switch to another optimization, which is pretty cool. So for example, if I choose direct RGB 565, which is what I showed earlier, those images are stored in 16-bit RGB format on disk in Flash effectively. So those are streamed directly from Flash in uncompressed form straight to the frame buffer, which means that now we're not using those intermediate inflation buffers and CPU cycles. We can use the DMA engines to draw those images from Flash straight through to the display buffer. So really that's it's a way of tuning things, and we can also do the same for TTF fonts as bitmaps instead of full font rendered glyphs and various other things. So this is a real powerful tuning mechanism we've introduced, and you can even do it on an individual basis. So if one particular image, if you wanted to store it as uncompressed or compressed, you can change it. Okay, so that's cool. That's basically how we staging for the deployment. Now what I'll show you is the actual deployment itself. So this is the I'll choose. Let's look at APK here. So what I'll do is I'll choose. Did I save that? Yeah. I'll go back and I'll show you. Show you basically what we're doing for this model. We can store it as a gap file and export it as files like we're seeing here. You could also theoretically you can package this up and store it as an Android application and load it on a tablet or a phone to preview. This is common for teams who are doing design and development way in advance of hardware availability. So you can show the marketing teams and other key stakeholders what it looks like, and they can give you feedback. Same for self-extracting exe. But in this case, what we'll be doing is we'll be deploying to an SB Engine model header file. So this is a structured header file with all of these assets deployed as binary blobs, and I'll show you that in a moment. So I'm going to choose my flash export there, and I'm going to create a header file that's going to send it out. So I'm not going to do that now, but I've already prepared one for the next step. So what that's going to do, it's going to create a header file. It's going to embed all of those assets, all of those binary images. Everything else is blobs structured as a kind of a pseudo file system. And that's going to be linked into your application. So we're going to be looking in the next phase of how we take these resources and then start to build a system around it. Okay, so I'm not going to save that. So I'll move over to the actual source code side of things now. Awesome. So now we're ready to really get down to business and take our design and deploy it to the target. So give you a quick overview of what we're planning to do. So we're going to be using Storyboard to get this running on the i.MX RT1060 EVK, which is a 1 megabyte SRAM based ARM Cortex-M7. So this has got an LCD resolution of 480 by 272 with a capacitive touchscreen. In terms of Storyboard, we're using the Storyboard middleware. This is the runtime library we include in the SDK, which I'll come into in a second. And of course, we're going to be exporting our assets, as exported models and images and fonts and scripts. And this will be in the Storyboard virtual file system format. In terms of development platform, we're going to be using MCUXpresso IDE 11.2. Of course, that's the ARM GCC toolchain. And we're also using the 2.8, I think it's 0.2 version of the MCUXpresso SDK, which comes with FreeRTOS, and of course we'll be making use of the PXP hardware, and I'll show you that in action. Okay, so let me switch over to my browser now. So if you want to go and download this stuff, so you can get Storyboard pre-integrated in the MCUXpresso SDK. You see here the 1061. I've included the Crank GUI middleware, so just remember to tick that, and that'll bring down. If I switch over to MCUXpresso, when you drag and drop that into the SDK folder, that includes 3 sample applications with Storyboard bundled. If I show you my small display screen, there you go. This is actually the board running the Hello World example, which I've flashed here. So I'll give you a quick run through of that. So if I kick that off and run, so I've put a few breakpoints in here, and I'll step you through what it does. Basically, we're using the standard software from the MCUXpresso SDK. No, I'm not going to do that. Okay, so the first thing we do is hit the main function. As you can see, what we're doing, we're using all the standard setup functions to initialize the hardware, and these come straight from the SDK. After that, we're adding a couple of tasks. So a main task, this is running the asynchronous graphics engine, and also a secondary task, which is going to be polling the touchscreen for input. So the hello task here is really whatever else your application's doing. Here it's just saying hello and then going to sleep. Okay, so it's really easy to add storyboards to an existing application with the addition of a couple of tasks. Now, in terms of middleware, we bundle Storyboard in the form of a few static libraries. So these are the runtime engine components for Storyboard. So the GRE and AIVs, or the virtual file system, the Lua and image processing, all that sort of stuff. GREL is the abstraction layer for the RTOS, specific to FreeRTOS there. And then we've got a whole series of plugins, which are the individual kind of components which make up the UI. So these are the render primitives that we use, so circles, etc. Okay, so if I hit that running, the first thing you'll see is we launch off and it starts basically the SB Engine main task, and this is going to be loading and running our model. So it does that once, and once that's done, it's basically initialized everything, and it starts executing. The first thing it does then is it's ready for display. So at this point, we're calling back out into code to allow you to initialize the hardware. we're using the standard LCD interface, parallel interface here, so we need to set up a clock and turn the LED backlight on. And the rest of this is basically just configuring the frame buffer to this physical aspects of the display, the size and everything else. So if you needed to change your display type, it's all in control within your application code rather than in the Storyboard engine. So this is just bringing the two worlds together. And then we're initializing the PXP transfer. So we're using this to transfer the buffer for the LCD from the frame buffer. So that's standard code set up there. And then as soon as we've got a frame to display, what we do then, and this happens the first time we've rendered a frame, the display update function, generic display update is called, and this is called every time we have a frame to display. So whenever the application UI is changing, we'll be calling this function. And this really is transporting that frame buffer through to the physical hardware using whatever transport you need. So here we're using the PXP transfer to kick everything off. Okay, so I'll let that go. And it's going to hit this every time until I remove the breakpoint. So you can see on the display we've got some simple graphics. It's not really, there's no touch input, there's no interactivity on this one, but it's just basically a storyboard version of Hello World. So it's using some nice graphics and animation to display a sample UI. So what I'll do is I'll show you the second application. I'm not going to run this one. I'm going to stop that now. What I'll do is I'll use this as a platform for running our application that we developed earlier. So if I flick back to Storyboard, you see here SB Engine model.h is what we exported. I'm going to copy that and flick back here and paste that in my project. Okay, so what that's done, that's brought in those model files and assets and resources into this SB Engine model.h file. If I show you that in action, it's quite a large file. You can see there's a bit of metadata here. That's just basically useful for revision control. The first thing we find is the model, and then if I go to the very end, you can see here's our Storyboard virtual file system layout. So this is a way of structured binary links to these blobs of hex encoded resources. So these are the raw images, and this is the index file, which is basically a root file system equivalent. So we're using that structure to represent the model files and assets. Okay, and in SB Engine task, we include that header file at the top here. Sorry, I'll just switch projects. I'll close all these to stop confusing. Okay, so in the task file here, at the top we're including now including that header file. So we brought in that design. He's basically pasting that model into the application. So I'm going to kick that off, building and running. So what we're doing is we're basically enabling you to once you've got Storyboard combined with your application code, so adding the additional tasks and such, it's very easy to basically round trip. So you're able to go back to Storyboard's desktop, move a pixel, move a block, add some more resources, re-export this header file, and once your core code, your runtime is enabled, your libraries are added and deployed inside the package, you're able to change things and update them very quickly. So once that's built, it's going to be downloading and running. So if I just show you a couple of things. In our library code that we provide some source code for the GREAL extraction layer. So this is a library which we give you a pre-built one, but you can optionally build this. And I mentioned earlier about the core dependencies, the base dependencies that we need. That's not very helpfully close my list there. So the base dependencies on an RTOS that we have in the application. So here's the abstraction layer code that allows you to platform this against FreeRTOS. So this is calling through to the FreeRTOS functions, which for timers, for threads, for synchronization objects, etc., etc. So that's the base layer that we're going to be building. So what this should do now is if I hit that and run, you can now see that the let me make it larger, in fact. So this is our application we developed earlier, and we've got all of our animation. So you can see the glow effect that we added, and we've got the increasing lure there, and we're able to go backwards and forwards between the screens. So we got a pretty much exactly the same as what we had on our desktop, and now that's with a few clicks that's been deployed to the target, and we're able now to start seeing what the application looks like in real life on a real target. So I'm hoping that's I've done it pretty quickly, but I'm hoping that's been useful for you. You're able to go onto the MCUXpresso site. You're able to pull down these packages. You're able to build and test your own stuff. Using the ready-made kind of packages we've got, and then replace them with your own designs, and that gets you up and running really quickly. So I think we'll leave it there. So if I just wrap up. Some key takeaways, really, we want to get you involved, so we'd encourage you to go and talk to us if you've got applications kicking off, or you're thinking about using Storyboard, or you want to develop applications for these NXP platforms. Give us a call. We want you to basically give it a try. So we do have some pre-built demo images, so if you head to our website, we've got a bunch of them already made for various boards, not only the RT boards, but also Linux-based platforms on the i.MX 8 and other devices. And of course, Storyboard is available as an evaluation version itself, so everything I've done today you can use the free trial for. So you should be able to start building and running with your own applications. So thank you very much for joining. We'll encourage you to go and check out some additional resources and videos on our website. We'll be hanging around afterwards for additional questions, and I think there'll be channels available for you to link up with Crank. So with that, thank you for joining, and we look forward to working with you in the future.